Hey guys, so now I want to talk to you about naming ionic compounds. So ionic compounds are going to always have a metal and a nonmetal, or they may have a metal and a polyatomic ion. So polys are on the pink sheet, the ones that have more than two elements. And then there's also a possibility it could be a poly and a poly. What I mean, there's only this one positive poly, ammonium, with another poly, or you could have that positive polyatomic ion, ammonium, with a nonmetal. So again, I highly recommend that you use a highlighter on tests and quizzes, or possibly just write, I next to the ionics. So I'm going to highlight. So my ionics, this one's not ionic because this is two nonmetals. These are both on the right of the staircase. This is, though. Sodium's on the left side of the periodic table. Bromide is on the right side. This one, they're both nonmetals. Both nonmetals. Here we have a metal with a poly. Two nonmetals, so that's covalent. There's an acid. Oop, there's another ionic. Another ionic. So let's do those. And then we will go on to the next page. So naming, you don't change the name of the first, the metal ever. Sometimes you need a Roman numeral, but we don't change the ending. And then the bromine, we're going to drop the ene, I-N-E, and put ide. So on the right side of the periodic table, those few elements, when they come second, which they will in an ionic compound, then we just take out their endings and add ide. So oxygen becomes oxide, nitrogen becomes nitride. Next one, iron. And iron is on my pink sheet. Remember, we're not going to use these Latin. So it's either going to be iron Roman numeral 2 or Roman numeral 3. So let's just do this so we don't forget. And then we're going to find SO4, and that's right here. So that's sulfate. But you can see that the sulfate's -2. So this iron had to have been +2 because they're in a 1-to-1 ratio. This Roman numeral 2 is because of that. So iron, Roman numeral 2, sulfate. Next one, Li is lithium. This metal doesn't need a Roman numeral. It's in group 1. It's always +1. Sulfur is going to become sulfide. Next one, magnesium's the metal. And then bromine, take off the ending and add ide. Let's go and do a few more. So again, I'm going to grab my highlighter and I'm picking just ionics. So metal, nonmetal, or a poly. Not starting with hydrogen because we're not doing acids. So let's try these. So Be is beryllium. It's in group 2. And then OH is somewhere right there, hydroxide. This one, K, is in group 1. That's potassium. And then MnO4 is somewhere. Sometimes I have a hard time finding these too. Do you guys see it? There it is. So this is permanganate. Notice I'm not changing the names at all on the polyatomic ions. I can't spell it though. I think that's right. So spell it exactly how it is on the pink sheet. We don't change the names for ionics. This one here is copper. And then sulfur becomes sulfide. Copper is one that needs a Roman numeral. You can see that, where is it hiding? Right here. So it's either +1 or +2. So sulfur is -2. You can see that here, or you can look on the periodic table. The group that it's in is always -2. So if this is -2, this 2 came down. This copper had to have been +1. That 1 came down. So this is going to be Roman numeral 1. Next one, calcium, does not need a Roman numeral because it's in group 2. It's always +2. Iodine becomes iodide. So take off the INE and put IDE. Next one, PB is lead. I do need a Roman numeral. Lead is right in here, so we'll talk about that in a second. PO4, somewhere right here. Phosphate. So I can actually reverse crisscross for this, I think. You can always check. So to me, I think that lead is Roman numeral 2. And if you're not sure, try it out. +2, the phosphates -3. So if we were going to write the chemical formula, we would bring down the 3, bring down the 2, but we'd put that in parentheses. So we're going to continue with ionic compounds, and now we're going to write their formulas. So for ionic compounds, remember it's a metal and a nonmetal, or a poly is involved. And when you do these, you do want to crisscross. So I'm going to find them. So the ones with the prefixes like di and mono and pent, those are not ionic, so I'm not going to pick those. I'm only going to pick the ones that are not acids and are not covalents. So those are my ionics. So when I do these, I would reverse what I was just doing. So calcium is in group 2 of the periodic table, so it's always +2. And then sulfide came from sulfur on the periodic table, which is -2. If you forget, sulfide's right here too. So these already add up to 0, and that's the point of crisscrossing when I write a chemical formula. So I don't need to. So it would just be CAS. Over here, next one, aluminum is in group 13. It's always +3. It's also right here. Sulfate is right here. SO4, -2. So this one, I'm going to bring down the 2 and bring down the 3. So I'm going to need 2 aluminums and 3 sulfates. I do want to put parentheses around and put the 3 on the outside. Let's do this one. This one's a fun one. Tin, Roman numeral 4. So it's +4. Sulfite is over here. SO3 is -2. So you can sometimes just see this. We would need 2 of these for every one of those to be able to balance charge and make it neutral. You could also crisscross it. And if you do, you're going to need to, I'll show you. So I can reduce this. We don't want to touch the polyatomic ion subscripts, but these 2 numbers, the 2 and the 4, are both divisible by 2. So the formula is SN SO3 2. Let's do a couple more. And again, I'm going to highlight the ones that are ionic. So none of these, those are acids. Oh, it's the same set of problems. Let me pull this over. Oops. Let's see. Okay, so let's just do a couple more. This one is ionic. That one is. This one. This one. That one. That one. We maybe won't do them all. Oops, there's one too. Okay, let's just do a couple more. So here we go. Manganese is my pink sheet, Mn. and they're telling me it's Roman numeral 2. That means it's this one. So manganese plus 2, and then phosphate is over here somewhere. Do you guys see it? There it is. I have a hard time finding them. So PO4 is -3. So we're going to crisscross, trying to get our charges to add up to 0, and this trick works. So I'm going to bring down the 2 and bring down the 3. So then my formula, and I don't have to show that work up there, is Mn3 PO4 parenthesis 2. Next, silver. Don't think it needs a Roman numeral. I think it's always +1. So +1, iodate. Somewhere. Here it is, I think. Right there. So IO3. And these are +1 and -1. They already add up to 0, so I don't need to crisscross. So that is my answer. My previous answer was there, so we don't know. And then this other is just my work. Let's just do a couple more. So potassium is in group 1. It's always positive. Carbonate is right there, CO3 -2. I'm going to bring down that 2, bring down the 1, which I don't really do, but so then I'm going to have 2 potassiums for every 1 carbonate, so the charges add to 0. Next one, we're going to get to use that positive polyatomic ion, ammonium. Ammonium is plus. Oxide is the element oxygen, which is -2. And that is right here also. But it's also in the group on our periodic table, so we know that's in group 16 is always -2. So crisscross. So NH4, I'm going to need 2 of them for every 1 oxygen. Let's probably be done. So I hope that helps. If you're struggling at all, I recommend that you decide, which ones are the ionics, do them all at once. Which ones are the acids, do them all at once. In the next video, we will do the covalents.